Thank you, everyone, for joining our November monthly virtual meeting of the Astrobiology Science Communication Guild. This is a special meeting that we like to host annually. This is our community sharings meeting. Today, we have several members of the Guild community who would like to share some of their science communication activities with us. This is going to be a great meeting, and I'm really excited to introduce Sid Pandey, Rajat, and Christian, who are going to each tell us different aspects of their SciComm journeys. And I think it would be best if you all give a short bio to yourselves. So let's start with Rajat. Please tell us a few things about yourself.
Okay, so thank you, Swet, for doing this. We're always looking forward to these meetings. So I'm a second-year astrobiology student in the University of Napoli. However, I'm also an engineer and a data scientist by training. And I will just tell the recent thing. I'm currently doing my thesis in astrochemistry, where we are trying to see if life-forming conditions, like if oxygen was being produced before photosynthesis occurred by plants, and if we can say that yes, panspermia is real. So this is what I'm doing right now, and we are active science communicators. So it's just a sheer pleasure to be part of the guild.
Oh, good. Well, I'm so glad to hear member feedback that the Guild is benefiting you. We serve the members, and we hope to, serve the member community. So I'm really glad to hear your positive feedback. Christian Sabbatelli, let's go to you.
Yeah, hello everybody. It's a pleasure to be here, and thank you, Svet, for this opportunity. I'm Rajat's course mate. I'm also studying astrobiology in Napoli and second year. And I'm also an astronomer, studied in Bologna, and I'm doing science communication in astronomy. And I'm also interested in Arctic environments. I've been in Svalbard, just came back 2 days ago. And also I will work on plant adaptation in extreme environments in my thesis. So yes, everything it's regarded to the astrobiology. It's my aim for the future career, and also science communication. It's very interesting for me. So thank you very much for this opportunity.
Thank you, Christian. Wow, Svalbard.
Yeah.
That must have been an exciting trip.
Yeah, it was like another planet.
I'm sure. Yes. Yes, I'm sure. Svalbard is an excellent Mars analog too. So that may be what you were studying there, I imagine.
Yeah, I wish.
Okay, Sid, how about you?
Thanks, Swet. So, hi everyone. I'm Sid. I'm originally from India. I'm a space systems engineer by training. I'm currently talking to you from Perth in Western Australia. I have lived, worked, and studied across India, US, and Australia primarily. Did my grad school in Europe, but didn't get to live a lot there, unfortunately, but hopefully get some time there. But my work has really been in developing technologies for space exploration, looking at sample collection strategies, developing drills and scoops and ways in which we can gather samples for astrobiology missions. I recently was at Jet Propulsion Laboratory working in the robotics team. We were looking at sample collection strategies for Enceladus. And I have been the last 7 to 8 years been involved with some community building efforts in India. And my talk is a little bit about that, so I won't go into that. But helping build astrobiology community in India and driving some of the analog research sort of collaborations has been my passion. So yeah.
Excellent. Okay, so the mic is yours. Who would like to start with their sharing opportunity? Let's go with Rajat. You're the on the top in my participant screen. So just by that random measure, let's go ahead. with your
Okay.
opportunity.
Thanks. So I'll share my screen.
Okay. And if Christian, if you both are talking together, feel free to jump in.
Yeah, we will talking together. We will freestyle a little bit.
Sure.
Okay. I hope everybody can see my screen.
Mm-hmm.
So in August, we received an email from Swed that that Europa TREK wants to add some new features to the portal, and they were looking. So they were looking for some subject matter experts for astrobiology, and because we are a member of the SciComm guild, we thought, yeah, let's do this. So
Rajat, can I just jump in for a second? Do we want to give an overview
yes,
of the Europa of the TREK science activation team? Would you like to do that, or would you like me to do that? Because I think it would be worth for our members to know about the TREK's group.
I think you can do that
Sure.
better. Yeah.
So within the science activation group, there are teams that are funded and teams that are considered infrastructure groups. And those are basically teams that are not actively funded to do specific deliverables within science activation, but they have, they're a sort of a resource. They're a group that have resources and are able to collaborate with the other SciAct teams. And so the TREK's team, headed by Brian Day, is one of these infrastructure teams. And the mission of the TREK's group is to provide visualization hosted online visualizations to planetary surfaces that are taken by different planetary mission instrumentation. So there was already a TREK in the system for Europa, and the team was looking to expand and add additional landforms to the Europa TREK, featuring astrobiology relevant environments, featuring habitable environments relevant to habitability for Europa. And so this is where the opportunity came in, and Rajat and Christian answered as our resident Europa experts, as our Europa subject matter experts, SMEs is what we call them. And they were able to work with the TREK's team to and add some enhancements to the Europa TREK. So that's what this project is about. So go ahead, Rajat.
Perfect. That was so perfect. And I would like to point out that Christian and I were not the only volunteers. There were other volunteers from different parts of the world. But for astrobiology point of view, yes, we were the two. And there were people from University of Bern about geomorphology. There were other people from other parts of the world talking about mostly geological features or volcanic features or tectonic activity. But we came in picture and we talked about what are the points of interest to find some signs of life. So how it started, as I told you in my introduction, we are science communicators. Before astrobiology students, we are science communicators. And we gained a lot of information and knowledge and some experience in our first year studies and now also. And we were looking for venues to apply our knowledge that we have gained, especially about metabolism and energy transformation and exchange. And we were very proactively looking for these opportunities to do that. And we came across the NASA Astrobiology SciComm guild, and it was super easy to get in. There was practically no entry barrier. You should you should self-identify as an astrobiologist in whatever capacity, and you become a guild member. And we started receiving these emails from Svetlana about various opportunities, various activities that we can be part of. And it was like unlocking a treasure chest because there was so much. But because we are not in on the US soil, we are not residents there, there were a lot of opportunities because they were paid opportunities and we cannot take them because we are not in the US. So the laws and policies prohibit us. So and again, there were many times such opportunities came that we couldn't participate in. However, we finally found something that we could, which was more of a volunteer role and not a paid opportunity. And we were like, yes, this is our opportunity to do something. And that opportunity was this project. And we started working on this project then. So it started as a small email from Swet. And right now, if you go on the SciComm Guild page on the NASA website, you will see this featured story. And it's been a very, very nice journey. And how we did it, what was our procedure, what was the thought process, what kind of knowledge we applied, I'll ask Christian to go ahead and present. I mean, go ahead and say, I'll keep
Yeah.
presenting.
Yeah, so basically what we did, it was to use this tool that is called Europa TREK. And so when you open a Europa TREK tool, this is what you see basically. And here you have the global map of Europa in 2 dimensions. No, the previous, yeah, thank you. So this is the 2D Europa global map. But you can also change projection here, clicking on the globe icon on the bottom left of the screen. You can choose to have a 3D dimension map as well as view from the moon from the North Pole or the South Pole. In the bottom right of the map, there is a fly to mode that it's this plane icon here, where you can, using that, you can basically insert coordinates to directly fly to a select regions that you want to explore. And then if you click on the icon on the top left of the screen, you can start the guided tour called the Landsform of Europa, in which we have to work. And so this is the tool that we use to select our sites of interest. So if you can go in the next slide. Thanks. So as subject matter expert in astrobiology and extreme environments, our main role basically was to identify location on Europa with the highest potential for finding signs of life. And these involved like analyzing structure features and assessing their astrobiological significance, basically. So our task was to consider possible metabolisms based on Earth analog, especially in some extreme environments, to determine where life might survive on Europa. And as you probably know, Europa is one of the most promising worlds in which we can find extraterrestrial life, thanks to its geological structure that is very particular. As you can see in this image, we have a icy crust that cover a global subsurface ocean. And the ocean, it's likely in contact with the mantle of the moon. And this mantle, it's likely heated thanks to Jupiter tidal effect. Basically, Jupiters are so intense tidal forces that they can cause the periodic stretching of the mantle, resulting in a fractional heating. It's called like this. Basically, this mantle stretch and through friction, it can be heated. And this heating is transferred then to the ocean and propagated via convection to the edge of the ice crust. And then this ice that it's heated breaks and places cracks and cavities from which ocean material can surface. And yeah, so we focus on 3 key elements to identify some sites: the subsurface ocean, the tectonic activity, and the chemical pathways that might support metabolism. So if there is life in Europa's ocean or in the cavities that the heated water digs in the ice, we think that the place where we can find sign of life, it's these cracks, basically cracks or ridges and other features where material comes from the subsurface. And in these cracks, what we can find is the end products of microbial metabolism. So, but what is metabolism in full words? So on Earth, we find life where we find organisms that do metabolism. And basically, metabolism can be represented by a flow of electrons from an electron donor to a terminal electron acceptor, passing through a carbon source. So in these kind of environments where there's no light, the electron donors is also the energy source. So we have a flow of electron by an energy source with a energy acceptor, we can say. So any kind of metabolism can be nicely schematized by that triangle like this one. That I think it's a very good way to visualize the work, how the metabolism work. So we use this approach, and with the help of some infrared spectrum that we find on literature about Europa surface, we identified some areas with the right mix of carbon sources, energy sources, and other essential materials for life. And we select them as promising landing site for Europa Clipper mission or later missions. So the sites that we proposed are in the two last slides of the Europa guided tour. And the first one that we propose is this one that you can see in this slide. This spot, it's like pond-like feature that catch our attention because it seems surrounded by some soft material. Indeed, this spot is also called soft center. This feature suggests something like low viscosity flooding that it's likely due to cryovolcanic activity, meaning that the subsurface fluids from Europa's Indian Ocean could be floating up to the surface in this area. And the presence of briny or possible sulfur-rich material here in this kind of features is significant, and it is supported by the infrared observation that we found in literature. And so if fluids from a subsurface ocean are present, they could carry compounds that are essential for life. And this makes this pond-like feature a fascinating site to study science of life, past or even present life, maybe. So this is the first location of interest we proposed. The second one, it's a more extended region that it's called Dyfed region. And this area, it's area with clear sign of tectonic and cryovolcanic activity, because in this region we can see ridges and separated ice blocks that allow salt-rich material to rise up from the below of the ice.
Rajat.
Yeah.
Sorry, I'm in the lab.
Yeah. So no, don't worry. So according to the observation, again, this reddish brown material is composed by salt of magnesium, sulfate, chlorine that might come from the subsurface. And this dynamic landscape suggests a continuous exchange between the surface and the subsurface material. And so as the ice moves, it could let nutrients and other compounds from Europa's ocean reach the surface and vice versa. And this exchange could potentially create the energy gradients needed to sustain life, making Dyfed region, but also other region of Europa a top location for astrobiological exploration. And then, to better understand what life on Europa could look like, we look to some Earth's extreme environments, like some ice caves, for example, or ecosystems that thrive under ice shelves, like in Arctic or Antarctic regions, as well as hypersaline glacial lakes or marine sediments or hydrothermal vents. And all these environments, in all these environments, life can prosper without sunlight, relying only on chemical energy. That is this energy source that you can see in this triangle again. And on Earth, these organisms provide a model for types of life that might exist in icy moon. So we create a table using the materials that we found in literature that they were detected on Europa, and we tried to create some metabolism using some Earth analog bacteria. And we've seen that in these regions of interest, we can have some metabolism, in particular, mostly perchloride reducing bacteria and sulfur reducing bacteria. So when we consider Europa, we imagine a similar possibility that lives not depend on sunlight, but instead it relies only on chemical reaction. And in other words, we are not just fantasizing about life on Europa, but we are basing on real-world biology, using Earth analog environment and apply that to study Europa. So yes, this is what basically we did. And yeah, I would like to say thank you for this project to NASA and to Astrobiology Science Communication Guild, because it was a great opportunity for us to, as Rajat said, to apply our knowledge. And I also want to say a very, very big thank you to Svet and to Brian Day, that is the elder of this project, and with which we are planning to use this approach also with some other icy moons or with Mars or with other planets in the solar system. So this will be amazing for us. And also a big thank you to all the volunteers of this project, because we were not alone, as Rajat said before, our professors and all our mentors around the world. So yes, this was our project in Europa TREK.
Excellent. Well, thank you so much, Rajat and Christian. Yeah, and I think this is a great example of a Astrobiology SciComm Guild and other science activation project collaboration. So thank you for bringing these groups together and showing us what's possible when Astrobiology SMEs can collaborate with other science activation teams.
Yeah.
Thank you. And I want to add one thing that is a very recent development in this table. According to one latest finding, there could be iron breathing bacteria also in the water column that is below the icy crust. So I highly recommend everybody to Google this thing called iron snow theory, and you can read more about this new type of mechanism that might be happening on not just Europa. They have done the studies for Europa, but it might be applicable to all the icy moons.
Okay, thank you for that extra, Rajat. Okay, let's move on to Sid and make sure we have enough time for your sharing for us. So please introduce yourself and take it away, Sid.
Thanks, Svet. So yes, let me just firstly share my screen and see if that works. Okay. You guys seeing my Protoplanet first screen?
We are.
Awesome, thank you. So it's taken us about 8 years to find a united, coordinated way in which we can continue building the astrobiology community in India. And Protoplanet is the result of multiple institutions, collaborators, and people sort of coming together and helping take scientific collaboration and field training for students to the next level. We are hoping we have a few ambitious things that we'd like to accomplish, but the first and foremost thing that we'd like to do is, as a new entity made of people who've been working in India for about 8 years now, it's almost like old wine in new bottle situation. we do want to demonstrate what we have done already in some ways or the other. So next year is our regrouping as Spaceward Bound India. So for those of you not familiar with the Spaceward Bound concept, it was essentially started at NASA Ames. It's a science-led teacher-student field education program, training program. It's been run in a few different ways at NASA, outside NASA. There's been an international version of it that has happened in various countries. And in 2016, we did that in India. So it's sort of an international community of people who have now grown over the last 20 years. That's sort of how long Spaceward Bound has been around. And Chris McKay at NASA Ames was the person who has been mentoring a lot of the international versions of Spaceward Bound. And 2016 was when we had done the first edition in India. And before that, it's happened in Australia, New Zealand, Namibia, other places. And we decided to take Spaceward Bound back to India. And that's what's happening. Spaceward Bound India 2025 is going to give us a reason to be back, to do more good things. And in the past, we've done it through different affiliated institutions. I have personally worked in India for 3 years at Amity University. We set up a Center for Astrobiology, and we ran a few expeditions through there. And we've had other host institutions also do similar things. But all in all, we realized there are challenges involved when you're trying to continue something that is sustainable and find ways to grow it. So we decided to come together and incorporate a new entity that is particularly in space education and capacity building. And that's what Protoplanet is about. The idea is also to integrate the Earth community and the planetary science community. So there are overlaps between, since we work in fragile ecosystems, there's a lot of information that is available based on field research, modeling that is being done by the Earth science community that we'd like to bridge with. And I think astrobiology gives a great reason for us to work as is within the planetary science community, but also find ways in which we can reach out to the Earth science community. So that's just giving a little bit of a background of what Protoplanet is. We are essentially three things. If I had to put Protoplanet in 3 words, one is training. We look at university student training, field training programs. The second is experience. We also work with people who travel and would like to have a meaningful purpose to it. So science-led, and this is where I guess your treks come in. We are looking at doing treks which are led by scientists and allow people the experience of understanding what it really means when you are trying to explain to people what climate change is and how visibly you can see the effects of it, but at the same time also see the value of how that natural environment can help you understand about another world altogether, right? So that's the second part. And the third is content. So we are very conscious of the power of storytelling, and Protoplanet plans to bring artists close to the science and work together to co-create content. And when I say content, I mean both short and long form content eventually, but to start with, probably under 10-minute sort of short film format videos that would be shot in different locations with professional artists to convey certain messages. So have a meaningful storytelling experience that is not really prescriptive, or it's really led by the people for the people, and not something that we put on a pedestal and have people sort of look up towards sort of a situation. So the name Protoplanet is something that we would like to convey to people that we are before something great. We are essentially what is the swirling dust gas that comes together to form a planet. So we feel we are the capacity builders, the facilitators, the people who are helping things happen, right? So the vision is to empower scientists, students, storytellers to come together, share the knowledge, and then create groundbreaking solutions in climate action and space exploration, try to bring those two aspects as close as possible to each other. That was the motivation behind choosing the name Protoplanet. And in essence, who are we? So there's a community of scientists who have come together in their own individual capacity and there's institutional partnership. So there's two different things to talk about. But essentially, the power is in the individuals who are backing this work. These are people who come from a varied background in earth and planetary sciences, who have worked in the field, in the outdoors environments. They bring with them the deep insights of the science and at the same time also of science communication. So we're very conscious of finding people who are not just good scientists, but also people who are good at engaging and training people, because that's what Protoplanet requires, and have worked across different environments. It's not just people who are only from India or from the US. We're bringing in people who have worked in different environments and also lived in different environments. This is just a subset of people who are contributing to our projects. I couldn't get everybody on one slide, unfortunately. It wouldn't do justice to everyone, but this is just to say that it's building on existing collaborations. This is not a group of people who have decided to come together for the first time. In various capacities, I have personally worked with each and every person who I'm speaking with within the network, and there are several new people who have come on board, and we are planning out some exciting activities together. We are trying to be as inclusive as possible, as diverse as possible, and what we really align on is essentially, the vision of Protoplanet, which is to train people, build out the experience, and also find ways in which you can engage with them. This is a photograph 8 years ago taken in Ladakh. This was the first time all of us sort of came together. There were 30 of us, came from different backgrounds. I was a PhD student back then. I didn't know what I was doing, but somehow everybody contributed, and we had a beautiful 12-day experience in Ladakh. And what that experience was that even till this date, we're all talking to each other, wishing each other on our birthdays. And surprisingly, there's no other group that is so active that I've been part of. And there's something to talk about there, which is to say that they were people who came from different scientific disciplines. We had our minor dramas and all sort of emotions that we went through. But what came out of it was something beautiful. I'll maybe talk about this slide first. We had, over the last few years, we've managed to train over 100 students in Ladakh. We've had 4 expeditions since the Space Urban in 2016. These are just some logos of the different expeditions that have taken place, with the exception of the last one, which took place in the US. But it was essentially, we are training a team of students to help us with our Ladakh expedition next year. But it's essentially been that resource building activity. But all of this work has led to, back to this slide, which is, we really focus on the research. The science is at the core of it. And I'll talk about the importance of Ladakh. And that's one side out of many in India that we've identified. Ladakh ticks a lot of boxes, and that's why we've decided to go back there. The focus has really been on the research. There have been students who graduated based on that 12-day expedition that took place, the samples they collected, and the field work that they did. But most importantly, it led to something which snowballed into what is now a small but fledgling scientific community focusing on astrobiology. We brought a lot of people outside the closet of astrobiology. They were working on astrobiology topics, but weren't calling themselves astrobiologists. There wasn't any funding available. ISRO was not using terms like analogues or astrobiology 8 years ago. But we've come a fair way, and I wouldn't attribute most of that happening because of us, but we certainly several of us had a role to play in helping shape some of those activities that ISRO is now endorsing. ISRO being the Indian Space Research Organization. We have contributed to their space science roadmap build. There have been several national level meetings that took place since that one expedition, research collaborations that came out of it with people within India. And all of the students that came and got mentored, several of them have still remained in touch with us and are actually now actively contributing and turning out to be emerging early career researchers, doing their PhDs in leading institutions around the world. Many of them attribute and testify the fact that it was that experience that they went through in Ladakh or in that analog environment that really helped shape their career decisions. And we are very proud of that. I think the power of analogs is only seen after a few years. It's not something that gives you something immediately. But looking back now, that's something that we'd like to continue to build in. Now, why Ladakh? Ladakh is this one location in India. It's in the Himalayas. It's a cold, high altitude, dry environment, desert environment. It's surprisingly pretty accessible. It's a 45-minute flight away from New Delhi. It doesn't seem too far. It's actually closer to New Delhi by flight than Mumbai is. But it's in this really remote environment that is slowly becoming a bit of a tourist hotspot and a bit of a concern, as most remote sites eventually will become, I think, Iceland and others included. But all to say that the government is very conscious of some of these places. They're now protected environments, come under wetland status. So there's some good hope there. But back to the use case of Ladakh, it's one of the most diverse analogs in several of our opinions. Within tens of miles, you are able to access sand dunes. You're able to drive on the same day to a hot spring site at 14 to 15,000 feet above sea level. So that high altitude bringing with it high UV radiation, low oxygen environments, and low atmospheric pressure, and all of those conditions that make it an analog to early Mars in the Hesperian age. We wrote a overview paper in 2019 that was the first sort of overview paper in Ladakh that helped characterize some of these sites. That was the objective of the 2016 expedition. The previous speakers were talking about hypersaline glacial lake environments. They're there. Several of those glaciers are receding, and only dry salt deposits are remaining, and that's a concern, and that's the climate angle to it. But all to say that there's a lot to unpack there. There's so much happening in such a small environment. It's a very complex ecosystem, and we've only started scratching the surface in terms of understanding what aspects of what we're observing can help inform some of the right from the hypothesis building all the way to even understanding what sort of microbes are living, what is their metabolism activity, looking to identify why certain phenomenon is taking place in a certain way. There's so many different things that we have been approaching. And our groups, the work that we have been doing has obviously been segmented into microbial work, geomorphology work, biochemistry, biogeochemistry work. So I can talk about the science, but all to say that it's allowing people to work in a team in one location and be able to talk across a breadth of different scientific questions. And that's the main beauty of an analog environment, where you can get people from different disciplines together and have them hypothesize and talk to each other. One anecdotal observation I will make here is in 2016, everybody was in Sokar, which is one of our work sites, and they observed dust devils forming over the lake, and they were lifting up salt. That led to an interesting discussion where they started looking at understanding ways in which salt might be lifting up microbes into clouds. And it was the initial motivation towards a hypothesis paper that they published in Astrobiology, which talked about how when Venus was in a habitable condition, salt-laden winds might have lifted up microbes into the clouds. And all to say that those sort of naturally occurring phenomenon, it's hard to imagine in a conference hall or in a classroom. And places like these help you identify ways in which you could hypothesize. And I think there's a lot to be said about that. The other aspect has been outreach. And in 2016, we visited 4 different schools. And ever since, we've had a strong connection with the local community. The people in Ladakh are so sweet and simple. They make the most of one of the most resourceful people in India, in my opinion. They're living in a very fragile environment that's changing at a rapid pace because of urbanization of the city, of the township of Leh. But there are people who live in these villages, in these far-off places, that get excited by the smallest of things. And it's so much easier for us to engage with them than it is with students from the urban crowds. And that's probably a phenomenon that happens in other sort of communities as well. But we've had a great amount of experience to building that relationship, and that that relationship that is not just about us going in with stuff and teaching them, but also helping understand their culture, and really getting to know many of those people on first name sort of basis. And that relationship is been helping us identify ways in which we can give back to the community. And that's a huge thing for us, because we feel that a lot of the technology that we're taking into that environment, and a lot of that data that we're collecting, has implications on some of the climate monitoring aspect of it. So the local government of Ladakh is working with us. When I say us, I mean Protoplanet, to figure out a way in which we can set up automatic weather stations, AWSs, at different locations, train some of the people to collect that data, especially in the months of winter when it's very hard to access some of these places. So a lot of that is leading to those sort of, I would say, useful side products of our presence in that location. We've been fortunate when it comes to support, both when it comes to financial and in kind. We've found ways in which we can target funding, not just from government grants, but also from corporate sponsorships. So companies like Tata, which manufacture SUVs, have provided us with vehicles in the past and funded us and given us some money to do like a short documentary. We've had GoPro providing us with cameras. We've had National Geographic Traveler India, who've covered us, done a centerfold story on us. Blue Marble Space, of course, has been instrumental in the foundational aspect of most of the astrobiology work that is happening in India. And as a affiliate member of Blue Marble Space, I cannot speak enough about their value in what we're sort of building out. There's been support from Earth Space Foundation. Design company Studio Carbon has helped us with a lot of the design work that's gone into things from the logo all the way to the plan for the habitat that I'll talk about after the slide. And SatSure, which is actually a satellite data analytics company, is actually coming on board as a partner again this year for next year's program. And they are a company that's finding innovative ways in which they can connect satellite data and the analytics of it and the outcome of it to farmers and people working in really remote environments in India. And both from the climate and the agriculture aspect, they're at the forefront right now in India and doing some really innovative partnerships and going beyond just the traditional sort of providing data to the government for some of their programs. So I think that's a summary of the work that we have done so far in terms of connecting people. It's a meeting ground, not just for scientists from different fields, but also for students who've never been into the field. And that's an environment, that's an enabling environment that we would like to continue leveraging to train students. We've been fortunate to get a lot of coverage in the news in India, and we've made sure that most of that information is not just in English language, but also in regional languages. So coming to next year, and this is a call out for some of the people who are on this call or maybe watching this recording later on, we are planning to go back in the middle of next year. We are hoping to finalize on the date of that within the next month or so. So the format of Spaceship Bound is essentially a 10 to 12-day expedition that would bring in scientists from a few different disciplines. There'll be a select number of students who will be part of that expedition, because the focus really is to train students and at the same time give them an opportunity to see and observe how scientists are working in the field and sort of observe the conversations that take place between scientists at the end of a tiring day. We're conscious of the fact that such activities in the field require some sort of a facility or infrastructure that can support the science as is taking place. So we are taking baby steps when it comes to setting up an analog station. Ladakh is a fragile environment. The place that we're working is super fragile when it comes to sustaining people. So we will be staying in homestays for most of the time, and in fact, all of the time that we are in the field, and only utilizing a mock-up of a dome facility as a day use sort of you can call it like a little shed that allows people to be harbored a little bit from the amount of sand and dust and wind that plays out there. So if you're trying to collect, analyze, and store samples, it'll be good to do it inside the dome. So we'll be setting it up for a period of 3 months, somewhere between July and September, because it's a lot of effort to set it up just for 12 days. So that then gives us the option to actually do a lot of engagement. So that's a space that's being worked out. We have a team that's actually building out the engagement plan and the education and outreach plan. So right now, what we have is a art and literature workshop where we'll be hosting artists and writers in that space who can, find ways in which they can create beautiful, medium, whether that's art or whether that's literature, that can then become part of the hab. It could be, displayed on the hab, or they could stay there and get the experience and build it out, and then we could put it up on the website. So all of that is being sort of scoped out. And we're also planning to do a under 10-minute short film that allows us to capture the story of how the people who have come together, and at the same time talk about, what is the potential of this sort of hab. We are very conscious of where we are. Like I said in the past, we've made sure that we try to minimize the footprint while we are there and dismantle it at the end of season, so that we're not leaving behind things that could seep into the environment, because it is a protected wetland. We are focusing on, eventually, as we sort of grow this out, we would like to have a program that's catered towards the training of students, and then also towards the travelers, so the experience aspect of it. And that's the program for 2026 onwards, where we'd have something that's more focused on students, that's a little different, more intensive in terms of the actual research, and the other one that's a little lighter on the research and more on the experience aspect of it. So I think those are the main points. I think I've covered most of that. This is just a rendering that I created on using AI to give an idea of the hab. It will be used, like I said, as a day use facility. We'll be setting it up close to Sokar on the shorelines, which has been the site where most of the folks in the community, in the team right now, are interested in to work in that hypersaline glacial lake environment, and at the same time have access to some of the other locations not too far away. And this is just the last bit, which is the studio aspect of it. So we are putting together a studio within Protoplanet, which is bringing musicians, natural history writers, photojournalists, and artists together to help create content. And this is a very exciting thing for us, because such a thing we have not at least seen in India so far, which is trying to bring a professional team of artists who are trying to build content together. So yeah, we'll see how that sort of also grows out. But those of you who are interested can look into it. And then as Protoplanet, we do want to expand. So we want to start with Ladakh because we're strong there, but we've actually mapped out at least 12 different terrestrial analog sites in India, and they're all very different in terms of what they have to offer. So we do see the program traveling to different locations and continuing finding ways in which we can train and engage with people. So that's what we are all about. So I invite all of you to look into this and find ways in which you can join us. So thank you very much.
Thank you so much for that, Sid. I think it's very interesting to see how you're covering all the bases. You're leveraging partnerships. You're thinking about community outreach and engagement aspect. You're thinking about arts and literature and engaging that community, and you're keeping the science first and foremost as well. And it's good to see all the partnerships you're building. And I also think it's safe to say that the astrobiology program is very intrigued by this. So let's continue talking and seeing how we can collaborate together on this. I think some of us are very excited in the program about this. So thank you for that. And let's keep talking about it. In the 8 minutes we have left, I actually would like to have Rajat talk to us about another opportunity that he wanted to share with us, a podcast opportunity. So I will encourage you all to if you have any feedback or comments or questions for about the first two sharings, please put them in the chat. And I don't know if we'll have time for much discussion today, but let's, Rajat, maybe a 5-minute or so presentation about your podcast, your astrobiology podcast, and then hopefully in the last couple of minutes, we might have a few more minutes for discussion.
Yeah, thank you. Yes, I'll quickly do it. But I want to say, Sid, great work. We are really looking forward to it. And thank you for bringing this in focus, the analog part of India. Okay, since we are short on time, I'll just run through it. So, um, Graham Lau, the host of Ask an Astrobiologist, is my mentor at Blue Marble for science communication. And that podcast is amazing, and it's more about technicalities of astrobiologists. However, because of SciComm Guild, I got opportunity to interact with a lot of middle school and high school students as part of Gene Lab, um, where we realized that students love the term astrobiologist when they hear astrobiology. However, if they have a lot of questions like how to actually become an astrobiologist, what does an astrobiologist do? What do we tell our parents? If we tell them we want to become an astrobiologist, and the next question is, so how to go about it? And they're clueless about it. So we thought, let's invite real life astrobiologists and ask them their journey into astrobiology. When was the first time they heard about the astrobiology as a scientific field and what they did differently, or if they were already a practicing scientist, how they pivoted their research into astrobiology direction. So these are the themes that we want to talk about in our podcast. And it was started as an Astrobio Buzz initiative. It's a community that we started one last year, and it has now 600 followers. We want to engage all the astrobiology community and science communication and journalism. Uh, and like I said already, everybody loves the idea of astrobiology. It's highly interdisciplinary, and there's room for everybody. But the bad part is there is some confusion if it's actually a real scientific field. How do I tell my mentors and parents and teachers? How do I convince myself? And what field to study in my undergrad? What courses to take in my college, university? So how to go about it? And the ugly part is just for the completing the sentence. There's nothing ugly about astrobiology. So the purpose is very clear: to go beyond the fascination, to give a realistic and practical guide on how you can actually become an astrobiologist and learn from different perspectives. We we talk to real life astrobiologists and get insights into their daily life as an astrobiologist. What exactly are they doing and what efforts they are doing in this direction. And largely community building, bringing everybody together and giving a sense of belonging in this whole world of space exploration. Our target audience, as I said, is pre-scientists, as we say, young students, middle school, high school, undergrad, who will be scientists one day, and right now they are on the path of it. And people they talk to about their careers, like their parents, teachers, counselors, mentors, and the likes. We are targeting, and that's why we keep a very friendly, candid vibe to it, where it's just about guiding. We are not preaching anything. It's not very technical. It's just telling them about how we chose this career. Like you can also choose this career. You don't have to be afraid. Like you can choose to become a doctor very confidently that you will have a very successful career. You can make enough money to have a family and fulfill all your dreams. Astrobiology is also that kind of a career where you can actually make a difference. Um, Format is very simple. We have we have two hosts, one guest. We are doing pre-recording right now, and once we get more comfortable, we'll do the live session, and we release the recordings in batches, like 3 a month. So we already recorded our first episode with Giovanni Santiago from University of Connecticut. It was a very friendly 2 hour talk. We are right now in the editing phase, and next up is Space Case Sara, as we all know. There's Sean McGlynn from LC Tokyo. There is Vanessa from LG Munich. There's our professor and very popular Donato Giovanelli. So all these are practicing astrobiologists and super fun, super motivating people. And we hope to release the first 3 episodes in January on YouTube and also maybe on Spotify if possible. I want to thank you, my mentor Gramlao, my SciComm mentor Gramlao, my co-host Christian that you guys met. Maya is also an astrobiology student in a second in one batch above us. All our guests and all our volunteers, and we are very happy to take any questions. And thank you, Swet, again for letting us talk about this. Thank you so much.
Thank you, Rajat. That was a great introduction to what could be a really interesting podcast for a lot of listeners. So good luck with that effort.
Thank you.
And as I posted in the chat, I think many of you in this audience would benefit from collaborating with each other and at least on 2 of the 3 opportunities presented here. So please feel free to connect, network, share your contact information. You can use the Slack channel for that as well, or just let me know if you'd like me to amplify any of your messages to other guild members. I'm happy to do that. And with that, I think I will say thank you all for attending this community sharings meeting. It was very interesting to hear about all 3 of these opportunities. Congratulations to you, and I wish you continued luck with your endeavors. And all of you who are doing SciComm opportunities, we'll probably have another opportunity for community sharings meeting next year, probably around this time in the fall. Maybe if there is enough interest, we could do 2 of them next year. So look forward to an announcement on that coming soon. This is actually going to be our last virtual meeting of 2024 because, as many of you know, December is the month for AGU. So many of us will be busy with the AGU conference, potentially an in-person event there if I get enough interest. So far, not a lot of guild participants are attending. So that's to be determined. However, in January, stay tuned for an opportunity at the AAS meeting for anyone attending AAS here in Washington, D.C. There will be a science activation workshop hosted by a group called the Universe of Learning, and it's going to be on educational resources, informal and formal educational resources and strategies for STEM engagement. So that will be of great interest to guild members. We are partnering with the organizers of that workshop, so we look forward to giving you more information on that as it develops. And have a good rest of your day. Thank you all so much for attending, and see you all next time.